Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Brooklands, not Brooklyn, which is a city in New York in the United States, but Brooklands because I think these blue lines are meant to be brooks in the land of the Sudoku, and it's by Damo89 or Damo89. I'm not sure how you pronounce it. Here are the rules. Normal Sudoku rules apply, which means place the digits 1 to 9 once each in every row, column, and 3x3 box. We also have doublers, where there are 9 cells in the grids are doublers, 1 per row, column, and 3x3 box, each containing a different digit, so you cannot have duplicates in the doublers. You have to have a different digit in each doubler cell. The value of a doubler cell is double the digit in that cell. And that applies to region sum lines, where box borders divide each blue line into segments with the same sum of values. So, for example, these two cells values must equal to the same as these 3 cell values. So say we had a doubler here, right? And say it was 1 or whatever. Then as an example, we could have something like, I don't know, 7, 8, and 7, 6. So the sum of these values would be 7 plus 6 plus 1 doubled, so that's 2, so that's 15, and it equals the sum of these two cells, which is 7 and 8, which is 15. And that's an example of how region sum lines work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So, the thing that pops out to my mind is this region sum line. You cannot have 2 digits being the same digit here. That means one of these digits must be double the other one, right? Because otherwise they don't add up to they don't have the same sum of values. Well, what happens if we make this the doubler? If this is the doubler, this is a normal digit, but then these can't be the same digit either. So this has to be a doubler also. But the problem is, if these are the same doubler and they double to the same value, these digits have to be the same digit, and we can't have repeats within the doublers. So neither of these can be the doubler. This then has to be the doubler, which means we cannot have a doubler in the same box, column, or row. So these are not doublers. This is then 1, 2, 3, 4. These are 2, 4, 6, and 8, right? Because these two are essentially double the value of this cell. We have this cell is equal to the sum of these 2 digits and the sum of these 3 cells. Sorry, these 3 cells. And the same sum of these 3 cells. That's not very helpful. The blue's kind of messing with me because, well, we have 1, 2, 3, 4, 5, 6 digits here. The sum of 6 digits is 21. The sum of 2 digits without a doubler would be max 17. So there has to be a doubler here, which means this cannot be doubler here. This cannot be doubler here. None of these can be doubled, and none of these can be doubled, because one of these has to be doubled here. This is at minimum 1, 2, 3, 5, 6, 7. So that is 1, 2, 3, 5, 6, 7. That's 6 plus 18, right? Because the thing is, this is 1, 2, 3, or 4. So you cannot have 1, 2, 3, 4, 5, 6, because that would eliminate all possibilities for that cell. So we have 1, 2, 3, 5, 6, 7 is minimum, which is 24. what's the maximum for the second largest doublet? It's 8. Because the thing is, the doubler here, there has to be a doubler here, and there has to be a doubler here. Otherwise, it adds up to at most 17. If we have 8 doubled, that's 16, plus 9, that's 25. If we try to go 8 doubled with 7, that gives us 23, which is less than the minimum for this. So it has to be 8 doubled with 9 in one of the spaces, and then 9 doubled, which is 18, plus 7 in the other space. So this is 8, 7, 8, or 9 here. This is 7, 8, or 9, right? Because either the 8 is doubled and it's added with 9, because that's the only way you add up to more than 23, and you have to be more than 23. Otherwise, so you can't do 8 doubled with 7 because that adds up to 23, and the minimum in this 6-cell region is 24 because of this 1, 2, 3, 4 possibility. So it must add up to 25 then. So these 6 digits must add up to 25. So it could be 1, 2, 3, 5, 6, 8. It could be a lot of combinations. Oh, wait. This cannot be 4. If this were 4, these would both have to be 8. And then one of these 8s would fail. So we know there's a 9 here. And we know there's a 9 here. One of these, though, has to have an 8. And the other one is 7, right? Because the 8 has to be doubled with the 9. So this can never... So the problem is, if this is 4, both of these become 8. And that eliminates all possibilities for the 8 being doubled. And then you have 7 doubled plus 9. But 7 doubled is 14, plus 9 is 23. And again, it's too small. So this cannot be 8, this cannot be 4. What can this be then? This has to be at minimum, again, 1, 2, 4, 5, 6, 7, right? 4, 5, 6, 7 adds up to 22, and 1 and 2 add up to 25, which is the minimum that we have to have because we have a maximum of 25 for the second doubler. So this must then be 1, 2, 4, 5, 6, 7, which makes this an 8, 9 pair here. This can't be 1 or 2. This must be 3, which makes this 6 and 6 to equal in value for the region sum. So 9 has to be here, 9 has to be here, which forces 9 to be here in column 3. Also, this can't be 6 because of this 6. This can't be 6 because of this 6. And the 9 has to be one of these 3 cells in row 3. Because we know the 9 has to be here no matter what in these 2 spots. So it cannot be here, cannot be here, has to be one of those 3 cells. That means we have a doubler here. That's interesting. Could be 1 doubled. Oh, 9 cannot be here and 9 cannot be here. So 9 has to be somewhere here too. Ooh, we have 9 with a doubler. What's the minimum of that value? 9 with 1 doubled and 2 and 3. So 9 with 1 doubled, so that's 2, plus 2 and 3. So 9 plus 2 plus 2 plus 3. 9 plus 2 plus 2 plus 3 is 2 plus 2 plus 3 is 7, plus 9 is 16. So this could possibly not have a doubler here. This could be 7, 9, right? Or this could be 1 extra, and this would be 8, 9. It doesn't have to guarantee there's a doubler here. We do know there is a doubler here, though, because one of these is doubled and one of these is doubled, which eliminates doublers here and here. Okay. What else do we have? Okay, this is 3 digits, which add up to the sum of 4 digits. This does not have a 9. What's the most this could be, actually, is kind of the question. You cannot have 6. You can't have 7 and 8. You could have 5 and 8 together. So 4, 5, and 8 is max. 4, 5, and 8. And in fact, 5 has to be on here, though. Because 5 cannot be here. Where's 5 in box 4? It has to be here, which means 5 has to be one of those 3. So say you had 4, 5, and 8. That's 9 plus 8, which is 17. So this could actually be a 9 here. That is possible. You could potentially have a doubler there too, also. I should have really used this as an example, because then that would have been pretty obvious. Oh well. We have an 8 and 9 already doubled. Oh, interesting. I don't think this can be 1, 2, and 3. Oh, wait. Yeah, okay, never mind. This is not 6, and this is not 6. Therefore, we need a 6 here, too. So this is 6 and 9, and we have a doubler. 6, 9, and 1 doubled by itself is 17. We have another digit adding up to the sum of this region's sum line. So therefore, this sum must be greater than 17 for these 4 digits. Well, without a doubler, you cannot have these sum up to greater than 17, and it must be greater than 17. So none of these are doubled. This must have a doubler, so none of these are doubled, and these can't be doubled. Yeah, I'm gonna change colors. I guess I'll make them gray. It's hard to see the blues when that happens. So this has to be 6 and 9 here. Whatever is not 6 and 9 here has to be in this row, right? Assuming it's not 7 or 8. Well, the 6 has to be here. The 9 has to be here. I think 7 and 8 are just too big. Right? You can only have 7 doubled with 9 now. Yeah. Well, you could have 7 here. 8 cannot be here no matter what. Hmm. 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 Ah, yes. Okay. If we try to make this 6, 7, and 9, we still have a doubler here. So that means it's 1 doubled at minimum. 6 plus 7 plus 9 is 22. Plus 1 doubled, which is 2, is 24. But the max we have now left for this doubler amount is 7 doubled, because again, we're using 8 and 9 doubled here. So this can't be 8 or 9 doubled. It's 7 doubled at most, which is 14, plus 9, which is 23. Therefore, 7 and 8 cannot be here. It has to be 1 through 4 with the 6 through 9. So this is 1, 2, 3, 4, 6, 9, right? But interestingly enough, this has a 5 here. Whatever are these two other digits, they can't be here, they can't be here, they have to be here, right? So that means this is at minimum, so this has to add up to at least 10, right? It's 4 unique digits, 1, 2, 3, 4, adding up to 10. So this must add up to at least 10 also. But remember, those two digits which are here, they either go here or they go here. Well, the thing is, we know 7 and 8 cannot be here. So the other 7 and 8 has to be here for column 4, right? Because wherever this digit is here, whatever digit is here, it cannot be in this set because it adds up to too much for this doubler and this normal digit to add up to. So it has to be here. And similarly, this one has to be in one of these two spaces here. But this one specifically 7 or 8, which leaves this as we have a 1, 2, 3, 4. Aha. Left in the column, right? This can't be 4. I don't think this can ever be 1, right? Because this is at minimum 1, 2, and 3, right? So this cannot be 1 here. This could be 2, 4, which makes this 1, 2, 3. Or it's 3, 4, which makes... So either way, this has to have 1 and 2 here. I don't think you can ever have a doubler here. Can you ever have a doubler here? 1 doubled plus 2 and 3. 1 doubled is 2, plus 2 and 3 is 7. I guess you could have that. 1, 2, 3 doubled with the 1 doubled here, and then this 3, 4. So that's a possibility. Unlikely, but a possibility. This is at maximum, so this has to be 1, 2, 3, 4, 7, or 8 as possibilities. And then this is 1, 2, 3, 4, 5. This can't be 4 though. So this is 3, 4, 5 at most. So this is 12 at most. So you can never have a 9 here. Since this is 12 at most, this is 1 through 6 at most here. This can't be 3 or 6. This can't be 4 here. We know 1 and 2 both have to be here. You could technically have 2, 3, 5 here and 1, 2, 3, 4. Oh, this has to be a 4 here, right? If this is not 4, it would be 2 and 3 at max, and that can't be the sum of 3 digits. So 4 has to be here, which means this can't be 4. So we act, well, I don't know. So 4 is either here or it's here. Again, this is max 23 for these digits. What does that mean though? Oh, I see something else different. What's the maximum value here? Sorry, what's the minimum value here? You can only have one digit that's from 1 through 4 here. So it's at minimum 1, 5, and 6, which means this single digit must add up to at least 12. Well, that means this is a doubler. So this is a doubler, which means none of these can be doublers here. This can't be a doubler, and these can't be doublers. So this is a doubler, this is a doubler, this is a doubler. So this must add up to at least 12. Because we have 3 digits here from 1 through 4. You can only have one digit here that's 1 through 4. So you can have 1, 5, and 6 at minimum, which means this is at least 12. So this has to be 6 or 7 here, doubled. This can never be 4. Okay. So whatever is here is the same digits as the other digits here. The problem is this must be at least add up to 5. So the other digits here must be at least 4 plus 1 doubled, which is 2. So that's 6. And then you have 6 plus 6 is 12, plus 9 is 21. You could have 6 doubled with 9 here. That is possible. So this is the 6 or 7 doubled also. So we have either 6 or 7 here, with 8 or 9 as the rest, right? You could have 7 doubled with 8, 7 doubled with 9, or 6 doubled with 9. Those are the possibilities. Because these 3 must add up to at least 10, because this is 4 digits here. So we have 6 and 7 doubled in these cases. Oh, that's interesting. Right. If this is 156, obviously this has to be the 7 doubled. And this must be 6 doubled. If this is not 156, that means everything else is greater. So this has to be 7 doubled, which forces this to be 6 doubled. That's interesting. Nothing that interesting, but it's still interesting to notice that. If this is 3 and 4, so see, this is 3, 4, 5. That means this is 3 doubled at least. If you have 3 doubled at least, I don't think that works. So 4, 6, 9 adds up to 19. 3 doubled is 6. 19 plus 6 is 25. So this has to be at most 11. So this obviously can't have a 6 here. So 6 has to be one of these digits here. This can't be 6. This can't be 6. So where is the 6 in box 1? It's here. 6 cannot be here anymore. 6 can't be here, can't be here, can't be on the region sum line because that would be too large for this digit. So this must be 6, which means this cannot be 6 doubled. This has to be 7 doubled, which forces this to be the 6 doubled. So the 6 cannot be here. 6 has to be one of those two and is not the doubled here because we already have a 6 doubled here. Therefore, this is 1, 5, and 6 here to add up to 12. This cannot be 1. This is a 2, 3, 4 triplet, which eliminates 2, 3, and 4 here. This is 1. This can't be 1. This can't be 1 here. This is 1, 5, 6. This is 7 doubled. It's with 8 or 9. So it's 22 or 23 here. This cannot be 1 doubled. This has to be at least 2 doubled. That's interesting. What's the minimum? 2 doubled with 3. So that's 7. 2 doubled with 3 is 7. Plus 6 and 9. Okay, so that does add up to a minimum 7, 8, and 9. So this is 8 or 9 here. This is 7, 8, or 9. This could still have the 1 doubled here. We don't know. This could be something doubled. We're not sure. This adds up to 12 with possibly a doubler also. I think the 2 has to be doubled here. If, again, yeah, you can't have 3, 4 doubled. So 2 has to be the one that's doubled here. Therefore, this is a 2, 6 pair here. Because the 2 has to be doubled. If you try to have a 3 doubled, well, could you have 3 doubled with 2, 6, and 9? Maybe, actually. 3 doubled with 4 doesn't work. So this can never add up to 12. But you could potentially have 2, 3, and 5 here, which adds up to 10. And that's fine because this is a minimum 10. So that would be 1, 2, 3, 4 if that were the case. 3 doubled with 2. So 3 doubled is 6. 6 and 6 adds up to 12. Plus 9 is 21. Plus 2 is 23. So that is possible. So this could be 2 or 3 doubled. We do know, though, the 2 has to be here. Because if the 3 is doubled, it's with the 2. Obviously, if the 2 is doubled, then the 2 is fine there. So this can never be 2 here, which means this is 2 and 5 with 3 or 4. So it adds up to 11 or 10 here. This again could be 6 or 7. So this is 1, 2, 3, 4. 3 cannot be here, though. So 1 and 2 both have to be here. 1, 2, and 3 all have to be here. Oops. 1, 2, and 3 have to be here. Because it's either 1, 2, 3, 5 or 1, 2, 3, 4 adding up. This can't be 6 or 7. But we don't know if we have a doubler here. That's the problem. You still could have a doubler here. with the 1 being doubled. Because this is 2 or 3. We have 8 or 9 here doubled, 8 or 9 doubled here, 7 doubled here, 6 doubled here, 3 doubled here. Oh, 3 can't be doubled here, so it has to be 2, 6 doubled. Okay, so this can't be 2. What does that add up to then? That's 19. Okay. So if we... That still works with 3 or 4. Okay, never mind. So it is 2 doubled because we have the 3 doubled already. Obviously, it can't be 4 doubled, because if you have 4 doubled, that's 8 plus 6 plus 9, which is already 23, without counting in the last digit, which would add it to 25. And again, 7 doubled plus 9 is at max 23. So 2 doubled with 6, that's 10, plus 9 is 19, plus 3 is 22, plus 4 is 23. So it could be either of these then. Mm-hmm. Okay. So 9 has to be one of these 3 cells here. 2 has to be one of those 3 cells there. Hmm. Ah, 1. Where is 1 in row 7? Cannot be here because one of these must be a 1. Cannot be here because one of those must be a 1. So 1 has to be one of these 2 here. It could be 1. No, it cannot be 1 with anything doubled. If it's 1 with anything doubled, and it would have to be 1 with something doubled because it doesn't add up to 12 with any other single digit. But if it's 1 with anything else doubled, the problem is that it's an odd digit with a doubled, which is an even digit, which would add up to an odd digit, which 12 is not. So this cannot be 1. This has to be a 1 here, which means this can't be 1. So 1 is one of these 3. Two is one of these 3 there. 2 could be with 5 doubled here. That's fine. What are the remaining digits, actually, in row 7? We have 2, 3, 5, 8, 9. But this can't be 2 because of the 1, 2, 3 or the 1, 2, 4 region sum line there. This can't be 3 because of that 3. So this is 2, 3, 5, 8, 9. But that could be any of those. So if these are odd, well, this is 2 doubled. Oh, this can't be 8. If this were 8, it has to add up with 4 or with 2 doubled here. And that doesn't work because this is 2 doubled already. So the 2 could be 5 doubled here. The 3 would have to be with a 9. The 9 would have to be with the 3. The 5 would have to be with the 7. So we don't know about that one. This must add up to 11. So this cannot be doubled. Actually, no, it could be doubled. You could have 2, 9, 3, 8. Cannot be 3 with 4 doubled. No 4, 7. But it could be 2 doubled with 7. Oh. No, it can't be 2 doubled because we already have a 2 doubled here. So that doesn't work. No 2 doubled with 7. 5, 6. Or 5 with 3 doubled. But if it's 5 with 3 doubled, the problem is that eliminates 3, 5 in here. So this can't be 9, 3 because that would not add up to 12. It can't be 2 with 5 doubled then in that case. So this cannot be 5 with 3 doubled. So this is never doubled then, right? The only possibilities that would be doubled here would be 8 doubled with 2, but we can't have a 2 doubled because we already have a 2 doubled here. And not 8 doubled with 2. It would be 7 doubled with 2. 7 with 2 doubled, sorry. 7 with 2 doubled. That doesn't work because 2 can't be doubled. 5 with 3 doubled. And obviously we can't have the 4 doubled here. And the 5 with 3 doubled, it eliminates all possibilities for this region here. So that can't be 5 with 3 doubled. So this has to add up to 11, and therefore is not doubled. 1 is already taken care of, so we don't have a 1. Where is the 1 doubled? The 1 doubled has to be one of these cells. Right? It has to be either here or one of these. Because the 1 cannot be doubled here, right? Because 1 can't be here, 1 can't be here. It's not doubled here because this is the doubler. It's not doubled here, here, or here. Can't be doubled here because of where it is, because this one of these two is a doubler. And 1 can't be here, 1 can't be here. 1 has to be one of these two, can't be here because then that can't be doubled. So this has to be the 1. It's not doubled. The 1 does have to be doubled in one of these two spaces. We need a 4 doubled also somewhere. Yeah, this has to be, so the box 3 and box 7 have to be where 1 and 4 are doubled, right? This is 2 doubled, this is 3 doubled, this is 8 or 9 doubled, this is 8 or 9 doubled, this is 7 doubled, this is 6 doubled. 1 and 4 cannot be doubled in box 9, so they have to be doubled in this box. Which means 5 has to be doubled in this box. So this can never be 5 here. This can't be 5 and 6 because the 5 has to be doubled here. This could be 2 with 5 doubled, or 5 is doubled in one of these two spots. Well, regardless, we know 5 has to be one of these two digits here. This can't be 9 because 9 has to be one of these 3 cells, and this can't be 9 either. Okay, so this can never be 3 and 9 here. If this is 3 and 9, that eliminates 2, 9 and 3, 8 as possibilities for this 11 cell, and that leaves all possibilities gone. So this must not be 3, 9. It has to be 2 with 5 doubled here. So this is 5 doubled. This is 2. This can't be 2. This is 3. And therefore, this is 2 and 4. So since this is 2 and 4, that's a maximum. This can't be 3. This is 5 or 8. This is 5, 8, or 9. This is a maximum of 1, 2, and 3. So this has to be not 1 doubled. So none of these are doubled, which means one of these two is doubled. So this can't be doubled. So this is the doubler here. So this is 8 or 9. We're not sure which. This is a doubler, so this can't be the doubler here, which makes this the doubler. So that's a 4, because we can't have 1, 2, or 3 here. So the 1 has to be doubled here, and it must be one of these two. So none of these are the doubler, which means this is the doubler here. So this is 8 or 9, and this is not the doubler. One of these 1s is a double. This can't be a 1, because these are the only places that can be doubled. And it has to be then 1 doubled with 2, 3, and 4, which makes this 2, 4, 5. So this has to be 2, 4, 5, which eliminates 4 here. That means this can't be 3. This has to be a 4, 9 pair. So we have 2 doubled with 6, 4, and 9, right? 2 doubled, this is 10, this is 23. So that makes this 7 and 9 here, which makes this a 5, 8 pair. Because again, this adds up now to 23. So this is 23, which makes the 7, 9 doubled. That 7, 9 pair eliminates 9 here, so this is 8. This can't be 2 and 9. This has to be 3, 8, adding up to 11. So this can't be 8 here, so this is 3, this is 8. That eliminates 3 here. This has to be 1, 2, 3, 4, adding up to 11, because the 1 is doubled. So this must be a 2 then. It can't be 4, and it can't be 3, and it can't be 1. So 2 cannot be here. 2 cannot be here. This can't be 1 or 3, so this has to be 4, which makes this a 1, 3 pair here. That eliminates 1 and 4 here. 2 can't be here. 4 can't be here. This is 1, 2, 3 triplet, which makes this a 9, and this is a 7 then. That eliminates 3 here. We have a 1, 2 pair in row 8, which eliminates 1 and 2 in the rest of the row. This can't be 2. This is 4. This is 2. This 1, 2 pair eliminates 1 and 2 here, so that's 3. 5 cannot be here, and these can't be doubled, and this can't be doubled because of the 5 here, so this must be doubled here, which makes this a 1. This is a 3. This 2 eliminates 2 here, so that's 5. This can't be 4, 5, so this is 2, which makes this a 4. This 1, 2 pair eliminates 1 here, so that's 6. This has to be 9, which means this can't be 9. That leaves us as 6 and 7, but 6 can't be here because of that 6, so this is 7, this is 6. These can't be 6 here. The 6 eliminates 6 here, and this can't be 6 either. Where is the 6 in box 3? It has to be here. That leaves us as a 3, 7 pair here. 7 is eliminated here, so this has to be an 8, 9, 8, 9 pair, which forces this to be 7. So this has to be the 9 doubled. This is the 8 doubled here then with the 9, because it must add up to 25, right? So 8 doubles 16 plus 9. This is the only place for the 7, so this is 8. This has to be not 8, 3, 7. 6 eliminates 6 here, so this is 2, this is 6. The 2 has to be doubled, so this is 2, which is doubled, which means this can't be doubled. So this is the doubler, which forces this to be 7 and 9. 9 eliminates 9 here, so it's 4 and 9. 7 eliminates 7 here, it's 3 and 7. This can't be 7 anymore. This 9 eliminates 9 here, so that's an 8, which makes that a 9. 8 eliminates 8 here, so it's 5, which makes that an 8. 5 and 7 eliminate 5 and 7 here, so that's 1. These can't be 1 then. We have 2 and 3 left here. This can't be 2, so this is 3. This is 2, which means this can't be 3. That's 7 and 3. Let's see, what else do we have? In row 2, we have 2, 5, and 8 left. This can't be 8, so this is 2 or 5, which forces this to be an 8 here. Okay, this has to be then an 8, 9 pair here. Those are the only digits that can be there anymore. So this is a 5, 7 pair. This can't be 5 because of this 5, so this is 7, which makes that a 5. That leaves 8 and 9 here, but this can't be 8 because of that 8, so this is 9. This makes that 8, which makes that 9. That leaves this not as an 8, so this has to be 8 here. This is 1. 7 cannot be here. Where is a 7 in box 1? It has to be here. So this is 7. That forces this to be a 4, 5 pair. That 4 eliminates 4 here, so this is 5, which makes that 4. This 5 eliminates 5 here, so that's 2, which makes that 5. This can't be 5 here. It's a 2, 4 pair there. That leaves 1 and 3 here. This can't be 3 because of that 3, so this is 1, 3. This 5 eliminates 5 here. It's 1 and 5. These are 1 and 7 here, and this can't be 7 because of that 7, so this is 1, 7, 1 eliminates 1 here, it's 2 and 1, 2 eliminates 2 here, it's 4 and 2. That leaves this as a 4 and this as a 5. And that's how you solve it. Yeah, not too bad, I would say. I don't know. I guess if you're used to doubler logic, which I am pretty used to, I guess, it does make it easier to see what things have to be where, right? I think the tricky part actually was finding this 6 and this 6, and then basically going, oh, the 6 has to be here, right? Yeah, it was basically eliminating 6 here because of that possibility. So 6 had to be here, which meant that couldn't be 6. So there was 6, and that was 6, which forced 6 to be here. And since 6 was here, this couldn't be a 6 doubler, so this had to be the 6 doubler, which forces to be 1, 5, 6. Which flowed, and then everything sort of flowed from there. Yeah. Pretty interesting. I like doublers, though, a lot, so it's fun for me to do these. And I hope you had a fun time watching this solve, and I'll see you next time on Frank Puzzles. Take care.